If you're using Xen Orchestra to manage XCP-ng hypervisors and you want to attach a USB device to a virtual machine, you might have noticed that there isn't an option within the GUI to do that. In fact, you've actually got to make the changes within the command line. But how do you enable USB pass-through for XCP-ng? Well, if that's something you're interested in finding out, then stick around and watch this video, because that's what we'll be going over. Now, for whatever reason, the devs haven't actually given us an option within XOA to attach a USB device to a VM. So the only option really here is to do this through the command line. Now, I'm going to be doing this through a series of steps, so for that reason I'm going to put a timeline in the video in case there's a particular section that you need to jump straight to. But the first thing we need to find out is what's the actual universally unique identifier, or UUID, of our USB device. Now, once you've plugged the USB device into the hypervisor, we'll need to get remote access to it. So I've logged in as root into my XCP2 server, and I'm using SSH to get remote access to it. That's preferable over, say, using the actual console session or a web browser and a shell session, because I can scroll up and down, I can copy and paste, so it makes my life a lot easier. But what we're looking for is the UUID of the devices that you've actually got plugged in. So I'm going to run this command, I'm going to copy and paste it. And what it does, it comes back with quite a bit of information about each device that it knows of, or at least that we've got access to, I should say. So in my case, it's come back with these two devices here. The key thing is this here, this line here, where it's over on the left it says UUID. So we've got two devices and each of them's got their own UUID, and this is the information that we want. Now, in my case, I'm actually running XCP-ng within ESXi, so that's why I've got two devices which have been described as VMware devices, but you'll get something back that's different depending on, what you're running XCP-ng on. But the key thing is, this is what you're looking for, the UUID. So after running that command, if you can spot your device in this list, all you need is that UUID, copy that, and then you can move on to the next step really, which is to go looking for the Group UUID. Now, in my case, my actual devices aren't showing up. There's no sign of them. And that's because the actual hypervisor is running a USB policy. It's actually blocking access to certain types of USB device. So these two are showing up no problem. Now, if I had a storage device, for instance, that would show up. It doesn't block those, but it blocks various types of devices, and specifically the types that I want access to. So one's an actual Zigbee controller, and one is a Z-Wave or Z-Wave controller, and they're not allowed within the hypervisor. It runs this policy for security reasons, and it blocks you from using them. So for me, the next step is to actually edit that USB policy to allow access to my USB devices, and only then will I be able to get the UUID from them. Now, if your device doesn't actually show up when you run this command, you need to update the USB policy to allow access to that device. So what I need to do is to first find out information about the devices. In my case, because I'm running two USB devices plugged into the computer, I need to find out the actual vendor ID and the product ID, because I'm just going to show you the actual policy itself. So I'm just going to type in more, and I'll just paste in the path. So you can see the actual policy that we're going to update is in /etc/xensource, and the config file is called usb-policy.conf. And you can see it's a series of deny rules and allow rules. Now, the allow rules are asking for the VID, the vendor ID, and the PID, the product ID. So that's information we need to allow access to these specific devices. So I need to find out what that information is first. So to do that, I'm going to run another command, which is LSUSB rather. And it comes back with all these USB devices. Now, I recognize those two as being the devices that I've plugged in. So one's a Z-Wave or a Z-Wave AOTech Z-Stick Gen 5. The other one's a Dresden Electronic Conbi 2 Zigbee controller. So that's my That's my Z-Wave controller, that's my Zigbee controller. Now, if you don't specifically recognize the device that you want to use and pass through to your actual virtual machine, take the actual USB device out, run that command again, and make a note of what's changed between this list here and the next time you run the command, because you'll see something suddenly disappeared. Now, plug that device back in again, run the command again, and it'll be back again, and you should be able to spot specifically which device it is. Now that one's pretty easy to spot because it's got a bit more information about it. That one, not so much unless you happen to know the actual manufacturer as well. So, you know, your results will vary, but as I say, taking the device out, run the command, plug it back in, run the command, should be easy enough to spot. But what we're looking for is this information here. So for my Zigbee controller, 1CF1 is the vendor ID, 0030 is the product ID. So once you've got that information, we can update the USB policy. So what I'm going to do is I'm actually going to make a backup of this actual config file first, and then what we'll do is we'll actually edit the file. So I'm just going to copy and paste this in just to make my life a bit easier. So that just basically copies the file to another one, and then we're just going to edit it, and I'm just going to use Nano to do that. And then I'm going to just scroll down to here where that's the first line. It's the first line that actually does anything, and it actually denies access to, well, USB display devices. But everything above it is a comment, so we can put our information up here. So I'll just move the cursor. Now I'm just going to paste in the lines that I need. And I'll just take these blank lines out. So what we've got is an allow option, followed by a colon, then vid, so similar to these ones here, because this is the vendor ID. So for my Conbi 2 Zigbee controller, the vendor ID is 1CF1 and the product ID is 0030. Now what follows is a hash and then some details about the device. So that's a comment. So whenever you put the hash in, anything that follows after is just a comment. And you can do that on the actual line itself. So I've done, you know, one line for the actual Zigbee controller, then this line for the actual Z-Wave controller. You don't have to put a comment in, entirely up to you. But for me, if I ever have to come back to this policy again, at least I know, you know, what device is what. So one thing to bear in mind is that once you've actually, you know, made this change to the policy file, like it says up here, you need to run this command XCP-USB-scan, which is basically to parse this file. So this is a recommendation. So I'm going to save the file now that I've put those two lines in. The only catch is to run this actual command, I need to know what the host UUID is. And that's the actual universally unique identifier of the actual hypervisor itself. So I'm just going to run another command. So I'll just copy that one in and paste that one in. So XE space host dash list. Now I'm logged into XCP2 and it's actually come back as the first device or hypervisor or node, whatever you want to call it. And that's its UUID. So that's the one specific to this actual host. So that's what I need to use when I need to run that command. So what we need to do is I'm going to copy in part of the command here. And then I need to paste it, copy and paste the actual UUID that goes with it. So basically we're running an actual scan. See, I missed the XE off there. So we're going to be running this scan on this specific host. So we'll run that. It hasn't actually come back with any errors, so that's a good sign. So once we've done that, I then need to run this Python script. And what this is going to do, it's actually going to run a scan of the USB devices, and it's going to go through and check against these actual rules that we've got on the USB policy. So we're running this specific command here. So it's USB_scan.py. So that's the Python script, and it's in /opt/zensource/libx. And I've got a -d option at the end, which runs in it's like a diagnostic mode. So I'll just hit return. Now, after running that, I can see straight away we've now got a reference to Sigma Designs, which I recognize as being the AOTech we saw earlier. I'm going to look and see, there it is. So there's my Dresden one as well. So it's run a scan using this specific policy that we've now updated, and it's now come back with information telling me basically it actually found those extra 2 devices basically. So when I run this command XE space PUSB-list again, you can see because we've updated the policy, it's now returning the information I'm looking for. So we've still got our 2 virtual mice here, but we've now got another entry for our Zigbee controller. So I've now got its UUID for my Zigbee controller, and I've also got my UUID here for my Z-Stick or Z-Stick Gen 5, which is my Z-Wave or Z-Wave controller. So now that we've got that information, you want to take a note of the UUID again, and then it's a case of we now need to find the actual group ID. Now the whole idea of this video is to enable USB pass-through for a device, to actually allow the hypervisor to pass through a USB device to a virtual machine. Now to do that with XCP-ng, we actually enable a parameter on the device. So I'm going to copy and paste a command in for one of my controllers. Just paste that in there. So the command is xe space pusb-param-set. So that's the actual command. And then what follows is the UUID for the actual device that we want to enable USB pass-through for. And then we're just setting this parameter to say pass-through enabled is true. So I'll just hit return. Now that gets that done for one of the actual devices, because I've got 2 here. Just paste the next one in. So it's just the same command. I'm just specifying a different USB device. So that will enable USB pass-through for those 2 devices, which means I'll now be able to use those USB devices in a virtual machine. Well, now that you've got the UUID of the device, you actually need the group UUID to be able to attach it to your virtual machine. So I need to run another command. Part of the input of that is the actual UUID. So I'll just paste in the command, which is that there, and then I'll just grab the UUID for my Zigbee controller, for example. Hit return. Now that is what we need for the group UUID. So I'm going to have to do the same again because I'm doing this for 2 separate devices. So again, I'll just paste in this command, and what it's after is the UUID of the device. So I'll copy that, hit return, and that gives me the group UUID for that specific device. So each one's got its own unique details, but that's the information that I need for my Zigbee controller, and that's the information that I need for my Z-Wave controller. Now, in order to attach a USB device to a virtual machine, we need the UUID of the virtual machine itself. And that's relatively easy to actually get if we just run this command, which is xe space VM-list. So after hitting return, I get a list of virtual machines known to the pool. So it's not just virtual machines that are running on this particular hypervisor I'm logged into, it's all of the virtual machines that are known of. So as long as you've given that virtual machine a meaningful name, then it's easy enough to identify that virtual machine you're looking for. Now in my case, the virtual machine is called Home Assistant, so there's its name-label. And right above that is the UUID that I'm looking for. So that's what I'll be taking a note of and using in a command to actually attach the USB device to the virtual machine. So we've got the information that we need, and we've enabled USB pass-through for our devices. So the next thing to do is to actually attach the USB device to the virtual machine. But the virtual machine can't be up and running at the time. It has to be shut down. So the best thing to do is to go into the operating system of that virtual machine and then power it down from there. That way you'll get a nice graceful shutdown. And then come back to the command line, and then you need to run a command to tell it the USB actual device that we're going to be using, as well as the virtual machine that we're going to attach this device to. So I'm just going to copy and paste this command for one of the devices. So the command is xe space vusb-create, and then we've got two parameters, one which is the USB Group UUID. So not the UUID of the USB device itself, it's the Group UUID. And then we've got the virtual machine's UUID. So this is how we tell it what device to connect and what virtual machine to connect it to. So I'm going to hit return, and it comes back with an actual VUSB UUID. Because I've got two controllers, I need to do this twice. Once for each device I want to attach. So the only difference this time is it's a different Group UUID because it's a different device I want to attach. Hit return, and that comes back with a different UUID. Now, if you want to actually detach these USB devices in future, you reference it by the VUSB UUID. But what you can do is you can actually use another command, which is xe vusb-list, and it will actually give you a list of these devices that have been basically attached. Right at the top is the VUSB UUID that you need to use in future. And below that, you've got the virtual machine UUID and US Group UUID. It's not that particularly easy to identify, I must admit, from this sort of information, but it's a useful command because all you're really going to ultimately do is use that line at the top, as I'll show you later on in the video, as part of like a maintenance routine section, how you can actually use that to detach a USB device from a virtual machine. But anyway, we've now attached our actual USB devices to our virtual machine. We've enabled USB pass-through. So the next thing to do would be to, well, start the actual virtual machine up. So I'm going to run another command because I can do this from the command line. And that's just xe space vm-start, then UUID, and then the actual UUID of the virtual machine. Now, this will take a bit of a while because it's got to power the actual virtual machine up. But once it's up and running, I'll be returned to the actual command prompt here. But then I can go off and have a look and see what state that virtual machine is through its, in my case, it's Home Assistant. So I'll basically log in through the web browser and have a look and see if it's actually recognized these USB devices. Because one thing to bear in mind is that even though we've attached USB devices, it's really up to the operating system and potentially drivers that may need installing for the actual operating system to be able to use these. Now, the results may vary depending on the USB device you're using, the operating system, and so on. But for me, I'm running Home Assistant as a virtual machine within XCP-ng, and it does detect those two USB devices that I've plugged into my server. So as you can see down here, there's even a notification. If I click on that, it comes up with a link saying, check it out. I'll click on that, and it takes me to the integrations page. So it's actually recognized that we've got a Z-Wave or a Z-Wave controller plugged in. It doesn't particularly tell me anything clear about that, but I do know there's a Z-Wave controller plugged in here because it's offering to install a Z-Wave JS integration here. On the other hand, it's a bit more obvious when it comes to the Zigbee one. So this is the Zigbee home automation integration. So this is where it's detected as an actual Zigbee controller, and it's actually telling me it's a Conby 2 made by Dresden Electronics. So it's a bit easy to identify, but either way, if you just plug two controllers, one Z-Wave, one Zigbee, yeah, your chances are you'll probably get these two same integrations popping up as well. It's outside the scope of this video really to explain how to go any further than this to set up Z-Wave and Zigbee, because the real intention is just to explain how to pass through USB devices to a virtual machine like Home Assistant, for example, in XCP-ng. Now, when it comes to passing through a device from a hypervisor to a virtual machine, we obviously want that virtual machine to be running on the hypervisor that has the devices plugged into it in the first place. Now, in my case, the actual virtual machine was powered up on XCP2, which is the hypervisor I've got these devices plugged into. But it may well have started up on XCP1, for example. But what I can do is I can make a change within the virtual machine to make sure that it does run on the XCP2 if it is possible. So for example, if XCP2 is out of commission, then the virtual machine would get powered up on XCP1 anyway. But at least we can set some sort of preference to try to ensure that it, most of the time, the actual virtual machine will boot on there, because obviously if it tried to boot off XCP1 it just wouldn't work anyway because there's no USB devices. So I've gone into the settings for this particular virtual machine and I'm going down to the advanced option. We scroll down, I'm looking for an option called Affinity Host, which is here, because by default this is set to none. So at the moment XOA doesn't have any particular instructions to say try to run this virtual machine on this specific hypervisor. It's just left its own devices. But what I can do is I can click on there and I can actually specifically tell it that I do want it to run on XCP2. And then what it'll do is after this, it'll always try its best that it can to put this particular virtual machine onto XCP2. Now, you have to bear in mind with the fact that I'm running XCP-ng within an actual another hypervisor, so it is a bit slow to respond, I must admit. But I've now set that preference, so it's now set to say XCP2. If we go over to click on the logs, click on advanced, you can see it's still set there, but I'm just going to click on save just to be on the safe side. I'm just flitting backwards and forwards because for me it's a bit slow to respond, that's all. But I just want to make sure that in future, if it can, XOA is always going to try and boot the virtual machine up on this specific hypervisor. Now, if you don't want to use a USB device with a virtual machine, then we have to actually detach it from the virtual machine, because we're basically using USB pass-through to give a virtual machine dedicated access to a USB device. And if we don't want to do that anymore, we have to detach the actual USB device from the VM. So initially what we had done was to attach the USB device to the virtual machine, and we made sure that the virtual machine was turned off. In this particular case, when we detach the USB device, we have to make sure that the virtual machine is turned on. For whatever reason, if you try to detach this actual USB device, it'll actually generate an error message and it won't let you. So do make sure that the virtual machine is turned on first. Next thing to do is to get the VM USB UUID. Now, if you don't already know what that is, we can run a command which is XCP-USB-list. And it comes back and tells you about USB devices that we're passing through to virtual machines. Now, in my case, there is only one at the minute, and this is the information I'm after. That first line, which is the UUID, because I need to use that in a command to actually detach the USB device from the virtual machine. So the command I'm going to use is this one. So I'm just going to copy and paste this in. So it's XE space VUSB-unplug followed by UUID equals and then the UUID that we've got up here. So I'm going to hit return. It'll take a bit of a while, and then it actually removes that actual USB device from the actual virtual machine. Now, if I don't want to use this anymore, what I can do as well is I can just destroy this. We don't need it anymore at all. So I'm just going to copy the VUSB UUID again from there. So this command is XE space VUSB-destroy. This is just going to take that VUSB away altogether. So if I run that list command again, it's completely gone now. There's no USB device actually attached to the actual virtual machine, and the VUSB that goes with it for attaching to the virtual machine is completely gone now. But obviously, if at a later date you want to reattach this device, you're going to have to go through that whole process of finding out its UUID, finding out its group ID, and then going through that process of reattaching it back to the virtual machine. Now, apart from the fact that we've got to go through the command line to attach a USB device to a hypervisor in XCP-ng, we've also got some extra maintenance to factor in as well, and that's because the UUID of a USB device doesn't actually survive a reboot of the hypervisor. In other words, the actual ID that the hypervisor is using for these USB devices changes. It gets assigned something completely different next time it powers up again. You don't get these sort of problems with the hypervisors where you're going through a graphical user interface, but we do get this issue specifically with XCP-ng while we're going through the command line. So just to give you some perspective, if I run the command vusb-list, ordinarily what would happen is that this would come back and it would show me two devices, a Zigbee controller and a Z-Wave controller attached to a virtual machine. Here it's coming back empty, and that's because the UUID has changed. If I run another command, just to get details about my USB devices, you can see that the devices still exist. So this is my Z-Wave or Z-Wave controller, and this is my Zigbee controller. But the key thing is these UUIDs have changed because those have changed, the group ID has changed, and it's the group ID that gets used to create that VUSB. Because that no longer exists effectively, those devices, they wouldn't be seen anymore. They're not attached to the virtual machine. So if you were to reboot the hypervisor, what you would find is, well, you'd power up your virtual machine and there's no USB device there anymore. So you've got to go through this more careful process. If you're ever going to actually, reboot the hypervisor, let's say you're going to actually patch it, for example, before you reboot it, do make sure to detach the actual USB device first. And that's covered in the the previous section where I show you how to actually run a couple of commands to actually detach the virtual machine, the actual USB device from the virtual machine. So that's these two commands here I'll show you. So there's that one to unplug it, and that's where you put the VUSB UUID. And then the other one, well, because everything's changing effectively, the UUID of the device has changed, you may as well just take out the actual VUSB itself anyway. So we just destroy that. So you run those two commands, then you reboot your hypervisor, then go through that whole process again. You can skip the process of having to actually allow the USB devices. That survives. That's not a problem. It's the fact that these UUIDs are changing. Now, you may as well run the pass-through again. So that would be the next step. Once you've got your UUID, you would then do another command to actually allow USB pass-through. Now, what I'm finding is sometimes that survives, sometimes it doesn't. So there's another command you can use to check it. So if I run this command here, so this is similar to before. Originally I had that would have been that part there, that instead of list it would have been set, and that was to set USB pass-through. This time I'm actually going to ask for a list of the parameters. So on that device there, pass-through enabled is set to true. So even though the UUID has changed, for that device, for whatever reason, it's survived. This particular one, interestingly enough, it hasn't. So if I do the same for that one, you can see it's pass-through enabled is now set to false. So you can't really rely on this to be set. So you may as well just go through that whole process. Pick up from where it's, where we do enabling the pass-through, getting the group ID and so on. Go through that whole process. Then reattach the actual USB device to the virtual machine. So it is a bit of a pain. It's much, much easier on a graphical user interface. With those hypervisors, yeah, just you attach it and you forget about it. This, yeah, it's a much, much more complicated process, I've got to admit. In fairness, I don't think this is something you normally find in an enterprise environment anyway. I haven't come across, throughout my career anywhere where they specifically do USB pass-through. I've never seen a need for it, because typically what you would be doing is you'd have a virtual machine that's supposed to be surviving, a physical failure of a computer. The expectation is that that virtual machine would get migrated across to another hypervisor if the original host were to stop working. Now, if you've got an actual USB device plugged into an actual physical computer and the virtual machine's relying on it, well, the physical USB device isn't going with it. And so in that case, it doesn't really make sense anyway. You're losing out on that feature by having USB devices in the first place. But either way, when you do have a USB device that you do need to use by a virtual machine, yeah, you've got to pass it through from the hypervisor to the virtual machine. Just in the case of XCP-ng, or at least Zen Orchestra that gets used to manage it, it's a much more complicated and slower process, and you've got this extra maintenance to bear in mind. As soon as you reboot that hypervisor, you can't expect it to carry on working again. Unfortunately, you've got to repeat the process. Now I'm going to include this extra section on troubleshooting for the USB policy in case you ever run into a similar problem that I had. Because when I first ran the actual process, I mean, I've got the process from the XCP-ng documentation, but when I actually ran that process for the first time, it didn't work for me. Now, I suspect that's because I'm using multi-class USB devices. They're not just a specific class of device. They've got multiple classes to them. So, for example, the Zigbee controller, it's a Class 2 and a Class A device, I think it is. And because it matched two different classes, the USB policy at the time was refusing it access. And I had to make some changes to get around that. Now, before I did this actual video, I did actually patch XCP-ng, and I suspect they've changed the policy. So if I edit this policy, I'll show you what I mean. So down here, that line there, there's a deny line for Class 2 devices, and then there's another line there for Class A devices. Now the Zigbee controller I'm using matches both of those two lines. Now originally when I first tried this, I'd put a line in like that one there, for example, which says allow access for this specific device, or at least these types of devices, because obviously it's, it could be any Conb2 device that I plug in here. They'll all get registered with the same vendor ID and the same product ID. It's not unique to the device itself. It's just the details for USB that define what is a Conb2 device. And what I was finding was that when I ran the scan, it would allow access, this line here would allow access for the device, but then I'd see hits against that line saying, nope, we're not going to allow it because it's a Class 2 device. And then I fixed that, and then it came back and said, nope, we're not going to allow it, this is a Class A device. Now, that's no longer a problem. As long as you've got that allow line, it does work now. But just on the off chance you run into some sort of like similar problem that I did, whereby you run the actual scan and you find that your USB device still isn't being accepted. This is what I was doing to get around it. So I'll just come out of here. I'm not going to save a change, because what I've actually done is I've blocked out these two lines now, because I want to show you if I run XCP USB list, you'll see at the moment all we're seeing is the two VMware devices, and that's because I've denied access, or rather I haven't allowed access for them. Now what I'm going to do is I'm going to run the scan. Well, actually I need to run the command first just to actually check that. So I need to run xe host-list. Then I need to just get that parsed. So that's XCP2. Copy and paste that. So that's run that command. And then what I'm going to then do is I'm going to run my Python script. I say mine, it actually is part of the hypervisor. But I'll run that script, and it runs it in a diagnostic mode. So you can see it's not coming back with any of these devices that I want to be allowed. So what I can then do is I can run the tail command to have a look in the log files. So if I paste in that, so I'm running the tail command. I want to have a look at, say, well, let's say I want to have a look at 100 lines, for example, of the user.log file. So it's /var/log/user.log, and we're running that pretty much as soon as we've run that scan. And then what you get is, if I just scroll up, you can see where it starts over here, and it starts giving you details about the devices that we've got, whether it's been allowed access or not. And you should be able to tell by going through that log what's actually stopping it from working. So for example, I can see if I go down here, there's hits against here, for example. There's a denial against a Class A device. There's a denial against a Class 2 device, for instance. So when I was running that command originally, let's go back into my policy. even though I had an allowed list, an allowed command in for that specific device, what was actually happening was it was then getting blocked as a class 2 device. So what I then did is, well, there's no point having that line, it doesn't achieve anything. So if we then comment out that class 2 device, just save that, and I'll run the command again to just to parse that file, and then we'll run our scan again. Find that, yeah, we'll run our scan again. So we still haven't found it. So I'll have a look in the log file. And I know there's blocks down here, for instance, still against a class A device. So I'm looking for that again now. So in which case, well, let's unblock the class A types this time. So I'll block out that deny rule. Save that. We'll run our scan again just to make sure that the config file's okay. We'll run our scan again. And you can see how this time it's picked up the Zigbee controller and the Z-Wave controller again. And that's the way I got it working, because I know when I did it originally, these were the sort of things I was picking up, where it's saying there, class A is false. We found a matching rule for class A and it just denied it. So kind of what I must admit, and I suspect it was as they would say, it's a feature. The policy, normally when it comes to security policies, usually what you tend to do is as soon as you find a matching line, you don't go any further, you stop. For some reason, this particular scan, if you will, it was actually carrying on, it was just continuing on. So what I was finding was that even though I did have a line that said allow, I mean, like that, for example, and it was getting a pass, basically say, yeah, that's okay, that's you've allowed this device, we'll allow it through. It was still refusing it because of these two lines here. And that's the way I found it out, was to literally just keep running the scan, having a look in the log file and seeing which particular lines it was that was actually blocking access. Now, in my case, like I say, that's no longer a problem, but there's always the potential something could happen, something could change. So it helps to know about this sort of information. I mean, there's other information, like here, for example, this is actually saying that it's allowing access for these, which are class 3. So you could put those snippets in, if you will, and say, oh, this is a class 3 device and so on. But for me, it was a case of, yeah, I was just denying the actual, I was blocking out the deny rule for the specific classes, and that resolved the issue for me. So hopefully you won't run into those problems, but if you ever do, that's how to actually try and troubleshoot the actual USB policy. Well, thanks for making it to the end of this video. I really do hope you found it useful. If so, then do click the like button and share, because that encourages YouTube's algorithm to suggest it to other people who might find it useful as well. If you're new to the channel and you'd like to see more content like this, then yeah, do subscribe. Just remember to click the little bell icon though, that way you'll get notifications when I send new content out. If you've got any comments, any suggestions, if you want to leave any feedback at all, please post that in the comments section below. And if you'd like to support the channel, I've left links to both Patreon and PayPal in the description below. But above all, thanks very much for watching. I'll see you in the next video.